Hello, my teachable student, and welcome to our special class where we present the simplicity of the science subject. I am dear friend Mike Matthew. In our last video under this topic of discussion, which is angle of elevation, I explained what an angle of elevation is, and I'm able to solve two problems under the topic. So let me remind us a bit on what I explained under angle of elevation. I said angle of elevation has to do with an observer looking up to an object above his eyes level. All right, and I even went further to say that the closer the object is to an observer, or the observer is closer to the object, the more the angle of elevation. All right, and I said angles are measured in degrees. So if you see any value in degree, that value is an angle. All right, today I'll be talking on angle of depression. Whenever you are dealing with depression, they mention angle of depression. It means the observer is looking down. All right, it means what is looking at is below his normal height level. So there are things that are common to both angle of elevation and depression. One of them is this: the closer the object is to an observer, or the observer is closer to the object, the more the angle of elevation, or the more the angle of depression. Again, when the object is closer to the observer, or the observer is closer to the object, the more the angle of elevation, or the more the angle of depression. All right, so when you see any given value that comes in degrees, just know that that angle is an angle of elevation or angle of depression. If you are here to watch any of our video, please go to the comment section and click the link so that you can watch all our videos. It's very important. All right, it's very important. All right, and like I said, always be a friend that encourages with your like, comment and share. God bless you as you do. So let me read out what I have in my note under angle of elevation. The angle of depression is the angle between the horizontal line. So when it comes to horizontal line, we mean the normal height level, the horizontal line, and the line through which the object, which is below the observer eyes, can be seen. So the angle is between two lines. One, the normal eyes level, that is horizontal line. The other one is the line of sight, that is the line that runs from the eyes, from the observer's eyes to the object. All right. So two lines, one horizontal line, the other one line of sight, that is the line that runs from the observer's eye to the object. All right, and the object is below the highest level. That is what angle of depression. And do not forget that angles are measured in degrees. So if you see any values in degrees, then those values are angles. Do you understand that now? All right, so now look at the diagram I have here. So you discover that we have the highest level, that dot. Okay, that's where the highest level, which is the horizontal line here, that is the highest level. All right, so now the observer look down to where an object is. That object is below the observer's eye. So we have an angle between the horizontal line and the slant line. That slant line is called line of sight. Okay, that is the line that connects the observer's eyes to where the object is. Now, if you now draw a line from that object upward to where the horizontal line is, you're going to end up with right angle triangle. Hello, when horizontal line and vertical line meet, they form angle 90. Again, when horizontal line and vertical line meet, they form angle 90 degree. Do you understand that? That is why when it comes to angles of elevation and depression, we are dealing with right angle triangle, because there are going to be an horizontal line, which is the normal height level, and there will be a vertical line from the object to the eyes level. So the point where they meet form angle 90 degrees. Did you understand that now? So now look at the second diagram here, because we can make use of alternate angle. All right, so now look at the diagram again here. All right, so this one, look from the upper one, we have the normal height level, which is horizontal. Then from that place down,
that is slant, I will call that line of sight to where an object is. So an object is actually here. All right, so we have an angle there, angle of depression between the normal height level, which is horizontal, and this line of sight, that is the line that runs from the observer's eyes to where the object is. There's an object here, okay? So that angle theta, all right? So now, if you draw another horizontal line like this, all right? So you're going to have what we call alternate angle. Don't forget, when you have two parallel lines and a transversal line, it will produce what we call alternate angle, and alternate angles are equal. Did you understand? So many a times, if you are dealing with angle of depression, please make use of alternate angle. Again, whenever you are dealing with angle of depression, make use of alternate angle so that you can have your triangle in this form. It means from this horizontal here, this down horizontal, you draw it up to where the observer eyes is. So that form a triangle down here. So this triangle is referable, all right, to the triangle we have here, all right. So you can make use of any of the two. So you can use the first one here. From the eyes, from the object, you draw a line, a vertical line to meet the normal height level. Then you're going to have a right angle triangle in this form, or you make use of alternate angle so that you can end up with a right angle triangle in this form. I hope that is clear. Now let's go to example 9. I read, a man observes that the angles of depression of two boats as 35 degrees and 42 degrees from the top of a vertical cliff, the foot of which is on the same straight line as the two boats. If the cliff is 20 meters high, calculate the distance between the two boats. Is that clear? Now, since they mention angle of depression, it means the objects, which are the two boats, are below the normal ice level. It means the observer is up somewhere looking down the two boats. Do you understand? From the question here, they said the observer is at the top of the cliff. All right, so he's somewhere at the top of the cliff looking down two boats, and we have the two angle of depression. So one observer, two objects. Do you understand that now? So now they said the foot of the cliff is on the same straight line as the two boats. It means they are what? On the same horizontal plane. Okay, let me explain something under example 8. All right, so when you have a bigger angle, the bigger angle will be close to the vertical line than the smaller angle. All right, so if you are close to an object that is above you, you have to look up more than when you are far away. All right, if you have an object up and you are far away, you just need to look up a bit to see the object. But if you are very very close to the object, you have to look up more. So it means the closer you are to an object that is above you, the more the angle of elevation. All right, so here too, all right, so here they give us two angles of depression. All right, so now when you are somewhere up and you're looking at two objects, all right, the one that is far away from you, you just need a little angle of depression. You need to look down a bit to see that object that is far away. But when the object is very close to you and you that is up there, you need to look down more to see the object below you. Okay, so it means when the object is closer to you, when you are far far up, you need more of angle of depression to see the object. Do you understand that? So let's go to the diagram we have here. Now look at the diagram here. So the diagram here, already I've drawn my right angle triangle. Don't forget we have an observer looking at two boats. So the observer is at this point, okay, and this is the normal ice level of the observer, which is horizontal. So now from that normal ice level, you look down a bit, that is 35 degrees, to look at a far distance boat. Okay, that one is at E. Okay, I label it at E. All right, then you now look further, you look further more, you look down more to look at the boat very close to him, all right, or close to the observer. So that's why we have 42 degrees. So we have an angle, you look down a bit to look at a far distance boat, then you look down more to look at a boat closer to him, the observer now. All right, so they gave us the height of the cliff, you know, is on top of the cliff, and the height given to us there is 20 in meters. Now I make use of alternate angle. If you need to make use of alternate angle, you have to draw another horizontal line, another horizontal line, and that's what I did here. All right, so let's go back to the first angle of depression, 35 degree, which is between the normal ice level and the line of sight from that observer's eyes to E, that is the distance both. I now draw another horizontal line. That is why we can talk about alternate angle, that if that place is 35 degree, then here will be 35 degree. So the horizontal line, I drew it further, okay, further to where DC is. All right, so again, the second angle of depression, you know, that is for the second boat closer to where the observer is. So that's why we have more angle of depression. You look down more. So 42. So if that place 42 between the observer's eyes and the line of sight, okay, to where D is from the observer's eyes, if that place 42 degree, then here will be what? 42 degree. Okay, 42 degree. All right, don't forget that the observer is somewhere up there. All right, so and the height of the cliff is what? 20 meters. All right, now, so if you look at this triangle now, or this shape, it has three triangles. So out of the three triangles, two are right angled triangles. Let us focus on those two that are right angled triangles with respect to C, because angle 90 is formed at C. All right, so let me bring out the first one. The first one is BCD. All right, we have that here. So angle 90 is at C. All right, that makes this triangle a right angle triangle. And then the second one is the external triangle, the whole triangle, which is what? BCE. BCE. All right, so and the angle 90 degree is at C also. So we have C in the first triangle, we have C in the second triangle. So that makes the two right angle triangle. Of course, you have to find the distance between the two both, and the two both, one is at D, the other one is at E. All right, so in that case you have to indicate a letter there. So put a letter, maybe X or Y. All right, so I put letter X there. All right, so letter X between D, E, and letter Y between C, D. Now we have to put a letter between C and D because letter C is very important, because that is where angle 90 is. So if between C, D is Y and DE is X, then the entire length between C and E, and that's what you have in second triangle now, is what? X plus Y. Okay, so X plus Y. Now in this case too, luckily in the first right angle triangle we have two known values. We are very lucky, two known values. Also in the second right angle triangle we have two known values. All right, so we have 20 meters here, 20 meters here, because there's a common side. All right, which is the height of the cliff. So common side 20 meters, 20 meters. But the one that is easier to start with is the first right angle triangle, because we have just a single Y, unlike the second one that we have X plus Y. All right, so we start with the second and the first right angle triangle to find the value of Y. But do not forget that you have to name the side. And out of the three sides, I said always name two sides first, which is what? Which are what? The opposite and the hypotenuse. So the opposite is 20 meters. Y is facing the given angle, which is 42 degrees. Then the other side, which is facing this right angle, is what? The hypotenuse. Even though we don't need this, but that place remain what? The hypotenuse. Then the third side becomes what? The adjacent side, which is letter Y. So using O, which is opposite for 20 meter, and A adjacent for the y meter. So OA is in tour. So we are going to use tan to find the value of y. So to be tan 42 degree is equal to opposite, which is 20 meters, over adjacent, which is y. All right. So tan 42, okay, using calculator or statistical table, is 0.9004. You can just put one under it to make it what? A fraction. Okay, then what you do, you cross multiply. So 0.9004 is multiplied by y, so we have it there. Then 1 is multiplied by 20, we have 20 here. So since we are looking for y alone, because from the diagram what you have is y, not 0.9004, it means that 0.9004 will have to leave that place. What do? You divide both sides by that 0.9004. So when you do that, y will be left alone. Okay, so when you divide 20 by that 0.9004, you have 22.212 in meters. Please always work with 2 decimal places or 3 decimal places. Do you understand? Now we succeeded in getting the value of y. Then let us move to the second right angle triangle. Of course, let us name the side. All right, of course 20 meters to remain what? Opposite. Y is facing angle 35 degree, and this side remain what? The hypotenuse. That side is what? The hypotenuse. Y is facing the right angle at C. Okay, so automatically x plus y remain what? Becomes what? The adjacent. So we are using the 20 meter, which is opposite O, and x plus y, which is adjacent A. OA, we get that in 2 also. So we are using tan. So to be tan 35 degree, all right, tan 35 degree is equal to 20, which is opposite, over x plus y, which is what? Adjacent. Do not forget, we already have the value of y. All right, if you like, you can substitute the value of y straight from here. I don't want to do that now. So now that 0 point, now tan 35 in using calculator or statistical table will give us 0.7002. You can put one under it to make it a fraction. So what you do, you cross multiply. Okay, so in that case, that 0.7002 will be multiplied by x plus y. Since we have two terms here, all right, you put those two terms in the bracket, meaning what you have outside the bracket, multiply the two things we have inside bracket. So it's equal to 1 multiplied by 20, that gives us 20. All right, so since what we're looking for is the unknown, this x plus y, it means that number beside x plus y will have to leave. All right, so what do? You divide both sides by the number, which is 0.7002. So when you divide both sides by that, it will cancel out. So you are left with what? X plus y. On the right hand side, when you divide 20 by that 0.7002, you have 28.563. Okay, but do not forget that we already have the value of y, so I replace that y by its value, which is 22.212. All right, so x plus 22.212 is equal to 28.563. All right, so on the left hand side we have two terms, one of them known value, the other one unknown value. On the right hand side we have a known value. What do? You shift the known values to one side. All right, so we shift that 22.212 to the right. So it was plus before, then it turns to what? Minus when you switch or you shift it to the right hand side. So when you take away, you end up with a with 6.351 meter. That is for x. Okay, but they said the answer should be in 2 decimal places. So what do? You convert that 3 decimal place that you have there to 2 decimal places. That is, you're going to have 2-digit number after that decimal point, which is 35. The next number after 5 is 1. It's not up to 5. What do? You round it down to 0. So your left is just 6.35 in meters. So we succeeded in getting the distance between the two bolts, which is D, line D, E. Is that clear? So please go back to all our videos, go and listen to them. You need them, it will help you a lot. All right, so listen to them, write if you need to write. You can be pausing the video in between so that you can write them down, so that you can have a better understanding. Okay, so please like our video, share, and comment. Okay, so from DFM Mike Matthews, I say thank you for your time. God bless you, and bye for now.